This is section 2-5, page 87, 1 through 54, even as the homework. All right, so a lot of this might be missed because I used my body to teach this lesson. So you will be missing me as a modeling an equation. All right, so addition property of equality. If I have a statement that says A equals B, if I add 2 paper clips to A and 2 paper clips to B, is that still an equivalent statement? If I add 2 paper clips to A and 2 paper clips to B, is that still an equivalent statement? A plus 2 paper clips plus B plus 2 paper clips. So our equation is really kind of sacred because it doesn't matter what you do to an equation as long as you do the same thing to both sides of the equation. Sometimes we can show it like this, add C to both sides. Or I can add it up and down. That's how we're going to be doing it. A plus C is equal to B plus C. Think of C like your paper clips. Now, when we add the same thing to both sides of the equation, that's what we call the addition property of equality. And if let's say I have 5 Jolly Ranchers in this group is equal to 5 Jolly Ranchers in this group. If I take 2 away from each group, will the groups be equal? Yeah, I still have an equal amount. What do you think we call that property when I take 2 away from each side? What do you think, David? Subtraction property of equality. So what operation you see is what we're doing. Okay. Pause the recording and finish the notes if you'd like them. All right, so now, if this is my equation, now this is where I use my body. Okay, if I am the equation, I am the equal sign. Okay, here I am. So this chunk over here is equal to this chunk over here. Okay, so x plus 3 over here is equal to 7. What happens if I take 3 away from this side when they're both equal on the scale? What's going to happen? It's going to go like this. Oops, this. It's going to go like this, right? If I take 3 away, you're right, it's going to go like this. It's going to be, because this side's going to get lighter, and this one's going to be heavier. Okay? The idea of an equation is that you have to do the same thing to both sides, or the fulcrum will tilt down. If I take 3 from the 7, what's going to happen? It's going to go up on the 7 side. But what happens if I take 3 away from both sides? It's going to stay the same. And that's what we do with equations. I take 3 from both sides. So when I'm showing it with an equation, once I cancel that out, because a positive 3 and a negative 3 make what? A positive 3 and negative 3 make what? 0. But I have x plus 0. What does that make? X. And 7 minus 3 is 4. Yes?
I've done this before.
Okay? So, algebraically, okay, I'm recording. Can you control? Thanks. So, algebraically, here's how we show it. I'm going to do the inverse operation so that I can get my variable all alone. So my variable is x. What's next to the x? Yes, Eva. What kind of 3? So what would I need to add to the positive 3 to make it become 0 and get that x all by itself? Josh? Negative 3. Does that make, what does that make when you have positive 3 and negative 3? Okay? If I do it to that side of the equal sign, I want to see it to the other. And then I write a line. Now, negative 3, positive 3, I want to see how they cancel out neatly. Don't scribble it so I can't see it. But what's left on that side of the equal sign? Yes. No, on the left side. X. Now, the one thing I want you to remember is I want that equal sign lined up right under the other equal sign. Does that make sense? That's the only thing I need to stay lined up. So now on the left side, I'm left with an X, and the right side, I'm left with a positive 4. Yes, Sergio.
Is it mandatory that you have to draw the scale?
No. This is what we're working on today.
Okay.
Okay? Now, can I erase that?
Yeah.
When you're solving these equations, oops, some books might write it like this, but I want you to do it like this vertically. Okay? Some books may put x plus 3 was the original. They may show the minus 3 like that, horizontally. I'd like you to do it like this. Yes, Lilith.
Why can't we just do the reverse one? 7 minus 3.
Because there's no property of equality. So her question is x plus 3 equals 7. Why can't I do this? Okay, because in mathematics is all about justification. The only reason we're allowed to do things is because of the properties. This does not show a property. This is a very elementary way of thinking about it. It's fact families. That's what they do in elementary school. Here, what I'm showing is which property of equality? Who knows the property of equality we're seeing there? What? So that's the subtraction property of equality. Says that if an equation stays equal if I do the same thing to both sides. Does that make sense? Lilith? Does that make sense? I'm glad you asked that question because you know what? I get kids in algebra right now that are rewriting it like this, 7 minus 3 equals 4, and they're getting kicked out. So we need to change that habit in 7th grade by showing our properties of equality. Because in geometry, you're going to be doing proofs. Every step you make, you're going to have to prove with a property. Okay? So, no more rewriting like a fact family. Okay, now here's the rules for transforming our equations. I'm going to put everything up and I'll highlight what I want you to write. Because I think you can abbreviate this, otherwise it'll take too long. So, goal, always. The goal, always. The goal is to isolate the variable. Okay? Number 2, same operation to both sides of equation. Same operation to both sides of the equation. Whatever I do to one side, I have to do it to the other side of the equal sign. And I'm going to say, what do we do next? And you're going to say, subtract 2. And I'll say, from where? Both sides of the equation. If you just say subtract 2, I'm going to mark that as wrong. Does that make sense? Because that shows me only subtracting 2 from 7 or 3 from 7. I need to hear you say both sides of the equation. Now, what am I doing to get the variable alone? To undo an operation, I always do the opposite operation to both sides. Near the variable. So let's say I see x plus 5. I'm going to subtract 5. Does that make sense? When you see plus 5, you're going to subtract 5 to get x alone. If I see x minus 5, what are we going to do? What am I going to do if I see x minus 5? Olivia? Add 5. If I see x multiplied by 5, what am I going to do? Yes. If I see x divided by 5, what am I going to do? Yes. We're going to multiply. Good. So it's always the opposite operation. Pause the recording if you need to take notes. So now we're going to do some inverse. We call this inverse operations. We do inverse operations by using properties of equality. So on number 1, what am I going to do, Paulina, to get the x alone? What do I need to get rid of? The 3. So what operation? What do I need to do to both sides? Subtract what? Subtract 3 from both sides. And then draw a line under it. I want it to look just like this. We're not drawing pictures. We're not sitting doing anything. We're writing this down. We're not waiting till I'm ready to switch the slide. Okay, and what's left? What's the new line going to read? Ava?
X equals 7.
Good. And I do want to see you canceling that out. Positive 3 and negative 3. And we're left with x equals 7. Now, think of that equal sign like it's in a cement pole. It comes directly down. Okay, what operation will I do next? What property of equality did I just use? Jeremy. Look at it. Look at the operation you see. What's happening to both sides? 4 operations. Add, subtract, multiply, divide. In this equation, so it's the subtraction property of equality. Everybody say that. Subtraction property of equality. Okay? Number 2. Shelley. What am I doing?
You are adding 8 on both sides.
Of the equation. Good. So, I'm going to add 8. What am I left with? Next line we'll read, Chris.
Y 0 equals 0.
Y 0?
Y equals 0.
Y equals what?
11.
No, because you're not adding up and down. Chris, look here. Negative 8 and positive 8 make what?
Negative 8 and positive 8 make 6, 8.
Negative 8 and positive 8. I owe $8, but then I earn $8. How much is in my pocket? I owe $8 and I earn $8. 0. Shh. Okay, so what's left on that side of the equal sign?
What's up on that side of the equal sign?
On the side where the yellow mark is. If the 8s are canceled out, what's left?
3.
There's no 3 there on number 2. What is left on this side right here? After you've canceled y. Okay? Now, when I add going up and down the 11 and 8, what do I get?
19.
Good. So I have 19 left on that side of the equal sign. Which property of equality are we using? Arpy. The addition property of equality. Excellent. All right, I'd like you to do 3 through 6. Pause the recording and then check your answer. All right, so number 3, what am I doing, please? Sydney.
You're subtracting 5 from both sides.
Good. The inverse of plus 5 is subtracting 5. Okay. And what will I be left with, Sarah?
N equals 6.
N equals 6. Number 4, please, Lilith.
You're taking 5 from both.
You're subtracting 5 from both sides. And what will the new line read? How will it read if I keep my x in exactly the same spot?
8 equals x.
Perfect. Love the way she said that. She did not make x jump to the other side. You don't do that unless you have a property that allows you to do that. Okay, what are we doing next? Olivia. Oops.
You have to add 3 to both sides.
And what will the next line read, Olivia?
15 equals n.
Perfect. Why is number 6 a little bit tricky? Alasia.
Because the variable is what it equals.
The variable's already isolated. It's already isolated, so I don't have to do an inverse operation. I just have to simplify one side. This gets simplified to one number. 11 plus 3 is 14, and k is already by itself. The only time I do the opposite is if I'm moving a number to the other side to get it away from a variable. Do you understand the difference there? Here, I had to get rid of a plus 5, so I did the opposite operation. But here, I'm not getting rid of anything, I'm just making it simpler. Does that make sense? The k is already alone. It's isolated. So all we do is simplify. Tonight, all right, let's try one word problem. Shh. Henry, how are we going to read the directions first, Henry.
Translate the sentence into an equation and solve.
So it's asking us to do two things. What?
Translate the sentence
And
solve.
good. Two things. If you don't do both of those, you don't get full points. So how would I translate the first problem? Sergio.
Okay, so it's k plus 13.
Okay, when I see an operation, I send it to the and. What comes before it? A k. What comes and means plus.
13.
13 is means equals 28. Am I done?
No.
What do I need to do next? Subtract 13. Thank you, Sasha. From
13.
both sides of the equation, I'm left with what, Sasha?
You're left with k equals 15.
Good. Okay. You guys do number 2. Pause the recording and finish number. All right. So tonight you may have problems like x minus -2 equals -10. What do I do here first before I begin my inverse operations with the double signs? Tiffany. Right. A negative times a negative really creates a positive 2. Okay? Now what would I need to do to solve this? You should be writing this down. Joshua.
You would have to do the inverse, which you would do -2 on both sides.
-2. I don't do, I subtract 2. I don't do in math.
And then you cross out the positive 2.
And what's left?
X equals -12.
-12. Then I use my rule of integers. Okay, yes.
Wouldn't it be a negative x?
No. Because I look at what the sign is here. Always to the left.
I know, but then the x would be negative 12. That would be negative.
No. X, there's no negative. Because there was no negative here or here. So the value of X is I owe $12. It's a negative amount. Because I'm doing X, take away the opposite of 2. Okay? So the negative sign has 3 meanings. Subtract, negative, and the opposite. So I could also read this as X minus the opposite of 2. Okay? All right, so with that in mind, I'm going to go back really quick so you can see the previous problems where we translated. It says the sum of k and 13 is 28. So the first thing we do is we read, we read, and it says translate and solve. That means 2 things. So as I'm reading, I look for the operation sign. I see sum, so I send it over to the and sign. Sum means to add. What comes before it, k. What comes after it, 13. Is means equals 28. And then I use my inverse operations to solve it. K equals 15. Now pause the recording and do number 2. Now check your work. The equation is 5 equals t minus 4. You need to keep the t exactly on that side and translate properly. Then use your addition property of equality, and you end up with 9 equals t. And that's the lesson for today.